Hey guys, so today we're back with part 2 of scientific notation. Okay, the topic is 8.2c. The student is expected to convert between standard decimal form and scientific notation. The student will know the difference between standard notation and scientific notation. You will understand that writing a number in scientific notation does not change the value, and you will be able to convert between standard form and scientific form with negative exponents. And again, we're focusing on negative exponents today. Yesterday we worked with positive exponents and we were expressing very large numbers using scientific notation. And so today we're going to focus on expressing very small numbers using scientific notation and using those negative exponents. Oops. Okay, so again, just a quick recap. Yesterday we talked about expressing very large numbers using scientific notation. For example, if we can take the number 84,000, we locate the decimal, we move it 4 times to the left to make it between a number greater than or equal to 1 but less than 10, and then we multiply it by 10 to the power of 4, and again we got the exponent 4 from the number of place values we moved the decimal. Okay, so scientific notation again is a way to write very large or very small numbers using the power of 10. And again, like I said before, today we're going to focus on expressing those very small numbers using scientific notation. And so the power of 10 is going to look a little different today. Yesterday we were using positive exponents, today we're using negative exponents. So here 10 to the power of negative 2 is not 10 times 10, but again since it's negative, now we're multiplying 1/10 times 1/10 and we get 100. If you notice the negative exponent, negative 2, okay, and if you notice the number of place values in our digit here, okay, we have 2 place values here, and we have an exponent negative 2. Okay, those are the same number of values, okay, within our answer. Let's look at this next one, 10 to the power of negative 4. So again, that's 1/10 times 1/10 times 1/10 times 1/10. And again, you can see why we're using scientific notation, because to write all of this out can get a bit messy. Okay. So again, 10 to the power of negative 4 is 1/10,000ths, okay? And again, if you notice, there are 4 place values here behind the decimal, which correlates to our negative 4 exponent here. And again, we want to write our scientific notation the same way as yesterday. Again, we have some number that is greater than or equal to 1 but less than 10, times 10 to some power. And again, our powers today are going to be negative because we are going to be expressing very small numbers to scientific notation. So here it says to write a number that is less than 1 in scientific notation means to move the decimal point to the right and use a negative exponent. So all the numbers that we're going to be looking at today, since they're so small, meaning that they're less than 1. Okay, so all our numbers today are going to be less than 1. And it says when the number is between 0 and 1, use negative exponents. So again, they're talking about our numbers are going to be less than 1. And they give us this example here. They give us 783 10,000ths, which is super small. Again, very less than 1, but obviously greater than 0. So they're writing using this scientific notation. Again, we have this some number times 10 to the power of negative 2. And again, it's negative because we started off with a small number this time. And again, it's just telling us that they moved the decimal 2 places to the right. Okay, so if you notice by the blue arrow, they moved it 2 spaces to the right. Okay, and that correlates with our negative 2 exponent. 2 times to the right, negative 2. And so again, I've written out some steps for us to follow when we're converting very small numbers using scientific notation. So just like yesterday, step 1, we're going to locate the decimal within the number. Okay. Step 2, we're going to move the decimal to the right until we have a number that is greater than or equal to 1, but less than 10, same as yesterday. And step 3, to figure out the exponent, we're going to count the number of place values we've moved to the right, and that will be our exponent. Okay. So here we're given the number in standard form. Okay, and we're going to convert it to scientific notation. So our number that we're given is 425 thousandths. So again, it's greater than 0, but it's less than 1. It's super tiny. So first things first, step 1, we're going to locate the decimal within our number. Okay, so here again, and I wrote it this way because I know we're going to have some number here in this first box. I know that it's automatic going to be times 10, and I just need to figure out the exponent. So again, I'm going to locate my decimal, which is right here before the 4. And then I'm going to move my decimal until I get a number greater than or equal to 1, but less than 10. And in this case, in order to get a number between that, I only have to move it 1 time. Okay, so when I move it that 1 time, I get 4 and 25 hundredths. And again, that's greater than or equal to 1, but it's less than 10. So then our next step would be to figure out the exponent. And again, I figure out the exponent by figuring out the number of place values I move to the right. And again, we're working with small numbers, or starting with a small number, excuse me. So when I move to the right here, I know that that's going to be my -1x. So our scientific notation is 4 and 25 hundredths times 10 to the -1. Okay, so we're going to work through this first example together. The question says write this very small number in scientific notation. So we're going to follow the steps. Step 1, we're going to locate the decimal. Step 2, we're going to move the decimal to the right. Again, however many times or however many place values it takes to get our number between 1 and 10. And in this case, we're going to move it 3 times. And so that puts our decimal here right after the 2, which equals 2 and 56 hundredths. So again, this number is what we want. It's between 1 and 10. And then step 3 is to count the place values moved and fill in our exponents. So again, here's our number times 10, and we just need to figure out our exponent. We moved 3 spaces to the right, but again, we started with that very small number. Okay, so we know that our exponent is going to be negative, and it just happens to be -3. Okay, so example number 2 asks us to write this number using scientific notation. So we're going to follow the steps. So we're going to first take our number, and I like to rewrite the number. Okay, and we know this is the form we're going to put our number in, so that's why I wrote that just like that. So first things first, I'm going to locate the decimal, which is right here, and then I'm going to move it however many place values to the right in order to make this number greater than or equal to 1, but less than 10. So it has to be between 1 and 10. So let me see how many times I'm going to need to move it in order to get there. So 1, but again, my number is still not between 1 and 10, so I keep going. 2, again, you can ask yourself, is your number between 1 and 10 yet? And this is still no. So I'm going to keep going, and I'm going to put this decimal right here. And that gives me the number 9. Okay, now I know that this number is between 1 and 10, so I can stop moving my decimal. And this is what's going to go here. Okay, so I'm going to put that 9 here. And you don't have to put the decimal at the end. You can if you'd like, but you do not have to. Again, remember, this is a whole number when the decimal is at the end like this. So it doesn't necessarily have to be there. And then the last thing I need to do is just figure out my exponent. So I'm going to count the number of place values I move to the right. 1, 2, 3, 4. And again, since I moved to the right and I started with a very small number, my exponent is going to be -4. So -4. Okay, we'll do one more example, even though I didn't have one ready. So we'll do example number 3. Okay, and I'm just going to think of some number. We're going to want to write this number here into scientific notation. Okay, so first things first, again, I'm going to rewrite my number so that way I can move my decimal and not get confused. And if you want, you can already have your scientific notation set up, because we know we're going to have some number here, and then what's going to be multiplied by 10 to the power of some number as well. Okay, so again, first things first, I'm going to locate my decimal, which is here, and I want to move it however many times to the right it takes until this number here falls between 1 and 10. So once, and my number is still smaller than 1, so I'm going to keep going. 2, so now my number is 4 and 378 thousandths, and that number is between 1 and 10. So here I can put my decimal here. So then I have this number, and so then this can go into my scientific notation. And then I just need to count how many place values I moved to get my negative exponent. And again, it's going to be negative because we started with a very small number. So here, 1, 2. So my exponent is -2. Okay, so what if we're given the scientific notation and we're asked to change it to standard form? So again, it's just like we're working backwards. So same thing as yesterday. If we're given the scientific notation, again, our step 1, again, our number is 8 2/10 times 10 to the -5, meaning since our exponent is negative, I'm automatically going to know that I'm making this number, or this number that's being represented, is super tiny since the exponent is negative. So first, I'm going to locate the decimal. Okay, it's right between the 8 and the 2. Step 2, I'm going to move the decimal to the left. Okay, however many numbers is represented in the exponent. And again, here it is -5. And we're moving to the left, guys, because it's negative. And I know that I need to make a small number. If I were to move to the right, okay, then I'd be making a very big number. But since my exponent is negative, I know I'm making a small number. So I move to the left to make that a very small number. Okay. So here I'm going to move to the left. My exponent tells me 5, so I'm going to move 5 spaces to the left. And again, I'm going to put that 0 in. And step 3, just like yesterday, is to fill in those placeholders with zeros. So then I get this very, very tiny number. All right, so we're going to work through an example. Okay. So here we're going to take 2 53/100ths times 10 to the -4 in standard notation. In scientific notation, and we're going to write it in standard form. Okay, so we're going to locate the decimal. Here it's between the 2 and the 5. And we're going to move it to the left again because our exponent is negative. 4 spaces because our exponent is 4, and we're moving left because it's negative. So we end up there. And then we're going to just fill in our placeholders with zeros. So the number that we get is 0.000253. Okay guys, example number 2, we have 3 2/10 times 10 to the -3, and we're going to write it in standard form. Again, we have our number, 3 2/10. Our exponent is -3. Again, the negative tells me it's going to be a small number. I'm going to move to the left. The 3 tells me I'm going to move 3 times. So I locate my decimal, 1, 2, 3, fill in my decimal, and fill in my zeros. Okay, guys. So sorry that was pretty quick. I was going to run out of time. Please catch the live for more examples.